Hi everyone, welcome to the Loophead. Today in this video we will be solving June Leetcode challenge, and the question for today is intersection of two linked lists. The question is easy tagged and it states that given the heads of two singly linked lists, head A and head B, return the node at which the two lists intersect. If the two linked lists have no intersection at all, return null. For example, the following two linked lists begin to intersect at node C1. The test cases are generated such that there are no cycles anywhere in the entire link structure. Note that the linked lists must retain their original structure after the function returns. Okay, so here what we have to do is we need to return the intersection point or the intersection node at which both the linked lists that we are given are intersecting. So in this case, we have A1, A2, C1, C2, C3, and B1, B2, B3, C1, C2, C3, and these both linked lists are intersecting at C1. Similarly, in the next example, we have 41845 and 56184 as the two different linked lists, and they are intersecting at 845. So we just have to return the head of this node, that is, return the node as head from where the intersection begins. So in this case, we'll have to return 8. So these are intersected at 8. Now next we have this 19124 and 324. So these both intersect at the node 2. So our output is intersected at 2. Now next we have these links. Since 264 and 15 have no common point of intersection, thus we'll return no intersection over here. So these were the examples. This is how what we need to do over here. That is, we have to return the intersection point of the two linked list. How would we approach this problem? The first approach would be to keep two pointers and start traveling each linked list. But in that case, what will happen is we will never encounter a situation where both pointer would be intersecting in such cases, because the length of linked list is different. So what we'll do is we'll just equalize the length, and since in this case the length of first linked list is 5 and the length of second one is 6, so the difference is 1, so we just move the pointer of the large linked list by 1, and now you can see they are parallel. They'll start parallelly and move until they encounter a node which has equal data. So it'll start here and it will move this way, and once it reaches over 4, it is just gonna return this. So this is what will be happening in our naive approach, but we can do better than this. Instead of just subtracting the number of extra nodes, what we'll do is we'll just start from the first node of each linked list itself, and we'll just start moving one at a time. Let me just help you visualize the same. So initially our pointers will be at the head of the each linked list. So the first pointer is at head of the first linked list, the smaller one, and the second pointer is at the head of the second linked list. And we'll just start traveling, and this will be moving one by one. And once the first pointer reaches at the last node of the first linked list, its position will be the next position would be the head of another linked list. That is, now it will be pointing at the head of the second linked list. And now once the second pointer reaches the um, last node of the second linked list, it will now start pointing at the head of the first linked list. Now you can see that the lengths are managed, and now they would be traveling equal number of iterations and would be encountering the same node and returning its value. So this is what is going to happen. So let me just drive you through the code. Okay, so the first case would be when any of the linked list is empty. In that case, there would be no intersection, thus we'll return -1. So if head A equal to none, or head B equal to none, in that case, we would simply return -1. So next we'll be having two pointers, that is L1 comma L2, which is equal to head A and head B, that is the heads of each linked list initially, until L1 and L2 are not equal, that is until they do not encounter an equal node, we are just gonna iterate them. So in case where L1 reaches the last node of the first linked list, we are just gonna point the pointer L1 to the head of the next linked list, that is head B. Otherwise, we are simply gonna shift L1 to L1 dot next, that is the next node. And similarly for L2, if we encounter the last node of the second linked list by the pointer L2, we are just gonna um, update our pointer's position to head of the first linked list. Otherwise, we are just gonna update it to the next node. So L2 is equals to L2 dot next, and we'll simply return the node where the where both the pointers intersected. So it can be either L1 or L2. I'm just gonna write L1 over here and let us see whether it is accepted or not if there is no error. So yeah, it is accepted, and let us try to submit this code and see whether this works or not. And I think yeah, it does. Let me just yeah. So it was accepted, and now so this was our sixth day streak. If you like this video, make sure to hit the like button, share with your friends, subscribe to my channel. Until next video, stay tuned. Thank you. Bye bye.